Good morning. Thank you for joining us today for this webinar Wednesday session for April 2018. And today's subject, we are looking at cavity barriers in external wall systems. My name's Katie, Digital Communications Specialist here at CABE, and I'll be acting as moderator for this morning's event. So how to interact with us. If you want to send through any questions, either on the right-hand side of the screen or to the top, depending on how you're viewing it, what device you're using, there's an option to send in some questions, and it's just a text-based system. So you just type them in and then they'll come up on my screen. And what we'll probably do is look to do questions towards the end. So feel free as we go along to send in any questions and we will pick those up. Alternatively, if you're viewing this on our YouTube channel, you're more than welcome to still send any questions over. Pop those over to info@cbuilde.com and then we will again pick those up and get back to you with the response. You can find us on Twitter. You can use the hashtag CABECPD. Your presenter this morning is Dr. Garry White. Now, Garry is a consultant fire engineer specialising in external wall fire safety. He has helped design the external wall of scores of buildings throughout the United Kingdom and is currently coordinating the BB7 response to building owners' concern about fire safety of their building external walls. He's a member of the Institute of Fire Engineers and is working towards Chartered Engineer status with the Engineering Council. So what I'm going to do now is I'm going to hand over, so if you give us a couple of seconds, I shall hand over to Garry and he will be able to take you through this morning's presentation. Okay, Garry, it's all yours.
Good morning. First of all, I'd like to thank Katie for inviting me along to do the webinar presentation, and of course CABE. As Katie said, I've been a specialist for fire safety on external wall systems for a number of years, and I've also written a number of fire engineering wall reports. These are not to be confused with the desktop studies that's been done, but we have written fire engineer reports as we're a fire engineering firm. And over the last 9 months, I've been out on the ground quite a bit to look at buildings, and I've noticed that there have been a number of interpretations and perceptions about cavity barriers, their fittings and their use. So I'm here this morning to talk to you about this subject. So what this presentation will cover this morning is, first of all, we're going to look at the relevant regulations and the guidance. We're going to look at the locations where cavity barriers should be used on the external wall, the fire resisting period of cavity barriers, exclusions from standard guidance, what materials can be used, the fixings for the cavity barriers, some terminology, and also we'll look at penetrations from accommodation. So first of all, building regulations, the relevant building regulation for this particular part, seeing as it's a concealed space, we're using a cavity barrier and a cavity, so that's a concealed space. So this is B3.4, and notice that if you read the this particular wording, you'll see this word shall, which means that you must do it. So to comply with the building regulations, which is the law, remember, you shall design it and construct it so that you don't spread fire within the concealed spaces. Now, this not only affects the external wall, but also the internal parts of the building. So it doesn't just focus on the external wall, it's for all of the building. So let's look at the guidance that we've got for a number of documents, and we're going to concentrate on one today, which is Approved Document B, Volume 2. I'm also going to mention BR 135 along the way. So you'll notice on the right-hand side of the slide here that we've got a diagram. And this diagram is from Section 9 and diagram 33. So in Approved Document B, diagram 33, you will see this particular document. And notice that I've coloured in some parts of the wall. So if you can see my mouse, I'm not sure if you can see my mouse, but there are orange parts where you've got cavity barriers, and there are cavity barriers in the external wall. And you've got cavity barriers around openings on the facade. So you've got this close around openings indication here. And around the openings, you provide a cavity barrier. And also in line with compartment floors and compartment walls. So here we've got a section through a wall. So we can see that we've got compartment floor cavity barriers, but this diagram doesn't show you some compartment walls. You'll notice also that there's fire stopping here. The fire stopping is inside the external wall envelope. Now, fire stopping can be used in the external wall also if you are unable through your design to provide a cavity barrier. So you may find that a cavity barrier doesn't really fit your design. So you could use a fire stopping element instead. And fire stopping is contained in Section 10 of Approved Document B. On to the fire resistance time for cavity barriers. This can be found on Table A1 and Item 15. So there, if you look at architect's drawings, you may find quite an array of different fire resisting times based upon preconceived ideas, ideas handed down to them, what we call grandfather ideas. But in the guidance, the minimum standard, and I do stress it's the minimum standard, is 30 minutes for integrity and 15 minutes insulation. And notice on the right-hand side it says each side separately. So that means that when we are looking at stopping fire going through a cavity, and not to be confused with fire stopping, then it's 30 minutes integrity and 15 minutes insulation. There are exclusions from this. The one exclusion that's in Approved Document B is on diagram 34, and it shows a section through a wall where you've got two leaves of masonry either side of the cavity. So you see an opening, and the opening could be construed as a window. And then you have your cavity running up and down. You've got two leaves of masonry. And where you have the masonry, it's deemed to be satisfactory or adequate if you close the cavity rather than use a cavity barrier. So the masonry's got to be 75 millimeters thick each leaf. So, and besides closing around openings, you should also close at the head of the wall. Now, the idea here is to prevent oxygen from being sourced to the fire itself. So in other words, you want to prevent oxygen being sourced to the fire. You stick a cavity closer at the head of the wall. What materials can be used? Well, there are a number of materials, and some are proprietary and some are bespoke. Approved Document B lists a number of materials such as steel. So steel is non-combustible, and if you use at least 0.5 millimeter thick plate, it will provide you with at least 30 minutes integrity. Timber, although it's combustible, can be a fire barrier. As an example of that, the window frame. If you've got a timber window frame and it's at least 38 millimeters thick, this can be construed as a cavity barrier. You can also use polythene sleeved mineral wool under compression. So these are purchased from suppliers. They come in a bag, and you fit them into, for example, 2 leaves of masonry. You can use a compression fit. And you can also use mineral wool slab under compression. So that would be a mineral wool batt, BATT, under compression, and the compression is normally about 10 millimeters. You can also use a number of building materials such as calcium silicates, non-combustible, cement-based or gypsum-based boards, not always non-combustible, but that's not really important part. The important part here is that they provide enough integrity and insulation so that they don't fail. And you can see that the minimum is 12 millimeters thick. You can also use intumescent putty affixed to mineral wool batt. So that's the idea. If you've got your mineral wool slab, on the end of that slab, you can then use intumescent putty, and this would be used typically in rain screen cladding, where there is a requirement for a ventilated cavity. And lastly, on materials, I did mention just a short while ago that window frames could be used as cavity barrier, and also if they're made of steel, they could be used as cavity barrier. Unfortunately, aluminium doesn't make a good cavity barrier, and nor does plastic, because they melt quite easily in the temperatures that you get in a fire. So on to fixings. Now the fixings should be firstly tightly fixed to construction and mechanically fixed in position. This is what the guidance says. So it's not just adequate if you've got anything other than 2 leaves of masonry to have cavity barriers not mechanically fixed. In other words, you need to have mechanically fixed cavity barriers if you're using anything other than 2 leaves of masonry construction. The reason for that is that if it's not masonry, it could move in a fire due to expansion of products, and therefore the cavity barrier is likely to fail if you don't fix it in. However, it's not always possible to do this, so where it isn't possible, you should provide fire stopping. Now, there is a big difference between the fire resistance of a cavity barrier and the fire resistance of a fire stopping item. For example, in a tall building where the top floor is 30 meters or above, you would expect a fire resistance value of 120 minutes, as opposed to the cavity barrier, which is 30 minutes integrity and 15 minutes insulation. The cavity barrier should be fixed so that environmental conditions, including building movement, will not affect them. it's quite easy for the building to heat up during the day, cool down later on during the day as the evening approaches. And also wind may affect the building. So it's important that any cavity barriers fitted are not affected by environmental conditions. Fixed so that their own fixings don't fail. Well, you would expect that they are fixed in a position so that their fixings are not going to enable them to fail. You would think that that's probably a given, but it's in the guidance, so I thought I'd put it in my presentation. Fix that no reliance is placed on any material on which they abut. So, for example, we mentioned that certain materials can fail, certainly if they're not masonry, they can move around in a fire. If the front panel is, it moves during a fire, and your cavity barrier is fixed upon the cavity barrier at the front, but it's not fixed to the rear substrate, then as soon as the panel falls off or delaminates, then the cavity barrier will be deemed to be failed. And you might say, well, you could say that if it falls off, you haven't got a cavity, which is true in itself, but if this is in the guidance, and therefore we should pay attention to it. So terminology in approved document B, this term cavity barriers, since I've been on air, I've been mentioning cavity barrier almost exclusively, apart from the cavity closer. So the term cavity barrier refers to all barriers in external wall cavity. Now, I did say earlier that it can be cavity barriers within the building, but within the context of this presentation, it refers to all barriers in the external wall cavity. In BR 135, the term fire barrier is used. So the BR 135 document is for cladding of buildings for multi-story buildings. So it's thermal insulation. The title of BR 135 is the fire performance of external thermal insulation for walls of multi-story buildings. And the term fire barrier is used almost exclusively. So this refers to fire barriers or cavity barriers where they are separating compartment floors and compartment walls. Now in BR 135, it doesn't really mention using cavity barriers at edges to openings on the facade, which includes windows and doors. But it does mention barriers in relation to compartment floors and compartment walls. So it uses the term fire barrier. So in fire engineering parlance, a fire barrier refers to a barrier that you are trying to separate different flats, if you've got a block of flats, different accommodation, if you've got different accommodation, whereas the cavity barrier we refer to around edges. So you would use cavity barriers at edges like around windows and doors, but you refer to fire barriers as those protecting compartments. And then the cavity closer is it's a material. It can be used as if you like an ad hoc way of closing a cavity. There are proprietary devices out there that call themselves cavity closers, but they do not qualify as a cavity barrier. So in other words, they're not guaranteed to have 30 minutes integrity and 15 minutes insulation. Remember, where you can use a cavity closer is with 2 leaves of masonry either side of the cavity. So we look at some typical cavity barriers here. Now you can see, if you can see my mouse, I've tried to illustrate where you've got the light blue, that's the insulation, and here we've got the orange part is a brick outer leaf, and you've got the floor slab labelled, and this is a section through a wall, and the cloud represents a fire barrier. So using BR135 terminology, the fire barrier. Now this one is a compression fit because you've got masonry at the floor, beg your pardon, you've got a sheathing board running down the floor slab. So it's actually been mechanically fixed in. So you'll see the pin on the slide. But it is a compression fit as well. So it's been compression fit plus it's been mechanically fixed. So it does comply with approved document B. And you'll notice that the cavity barrier is fixed all the way back to the rear substrate, goes all the way through the insulation, even though that insulation may be non-combustible. And you're probably looking at this saying, well, you've got, if you look at the dimensions on here, 125 millimeter, well, that could be a rigid board or it could be stone wall, mineral wall insulation. Okay, so now we'll look at a plan view. A window and the side of the window known as a window jamb, and we've got a steel frame system construction, lightweight steel frame, and that's been infilled with insulation. You've also got insulation in the front cavity. Again, you've got a brick outer leaf, and you can see that this time there's a cavity barrier which is acting as the protection, the fire protection to the cavity itself. Now the risk is that you get a fire in the accommodation, the window can break, and fire may be able to get into the cavity from the side. So the cavity barrier is providing 30 minutes integrity and 15 minutes insulation. Again, this one is fully compressed. It's about 10 millimeter, and it's been mechanically fixed back to the sheathing board. And we'll also look at some penetration through the external wall cavity. And I've made a little note on the left-hand side of the screen there where you can reference this a bit more if you can get hold of NHBC Standards Technical Extra, issue 22 last year. And you can see here that the representation is on the left-hand side an inner leaf, where you've got the red part of a pipe going through. So that could be, for example, it could be just a PVC pipe coming from the bathroom or the kitchen, and it's going through the external wall cavity. So where it goes through the external wall cavity, you need a cavity barrier. And you'll see where this brown part is, where here above and below, that actually means it's wrapped. So, for example, you could use mineral wool wrapping but it needs to be at least 30 minutes integrity and 15 minutes insulation. Now, where you cannot provide a cavity barrier because of your design, you may be able to provide fire stopping in the shape of a collar in the where the fire penetrates from the accommodation through the external wall. So you may be able to use fire stopping instead of a cavity barrier. So what I'm going to show you now is some cavity barriers that have been fitted to walls. Now these are, you'll note that these are testing walls, the full scale test British Standard 8414. And on this particular slide, you'll see mineral wall insulation and two sets of fire barriers. And I'll colour them in for you so that you can get an idea. So you've got vertical fire barriers, and then you've got your horizontal fire barriers. So the vertical fire barrier is fully filled, and the horizontal fire barrier has got this black material, which is an intumescent putty and is designed to start to char and expand as the temperature rises within the cavity. Now this is done for typically rain screen cladding, where you have a ventilation requirement in the normal operation of the building. But in a fire situation, you want the cavity to close because you want to cut off the oxygen supply, and also you want to cut off the fuel supply, which is any combustible materials above or below the barrier itself. Here we've got an illustration before the insulation goes on. So this has been mechanically fixed in place, and you'll notice that the vertical cavity barriers have got a mineral wool face. They are fully compressed when they fit onto the front panel, and then you've got the silver foil with the black face, which is the intumescent. Now those of you who are sharp-eyed may have seen that these particular fire barriers seem to be incorrectly fitted, and by that I mean that the intumescent should be linear and not punctured, whereas what we're seeing here is that the horizontal is punctured by the vertical. It should be the other way around. Again, we've got a close-up of what the intumescent and the fixing looks like for the fire barrier. Remember, these protect compartment floors, and so it's this material here, this black material, that will char up, known as intumescent, and it will then abut onto the front surface, the inside of the front surface. In other words, your rain screen panel. Thank you very much for letting me do this presentation, and I'm happy to take any questions.
Brilliant. Thank you very much, Gary. There have been a couple of questions that have come in. I know that potentially you may have covered them off a little bit earlier, but the benefit of those who have joined us perhaps since then. So the first question that we've got is, can cavity barriers be fixed outside the requirements of the product DOP without affecting the test certificate? So, for example, if the fixings are not used, but only compression fixings?
Well, if the cavity barrier is, if you're using a proprietary cavity barrier and it's not being used in the way that the manufacturer recommends, then there's a possibility that it may not carry the correct certification or warranty for that use. However, if you are using fire engineered approach, so in other words, some engineering, then that would need agreement with the approval authorities. So I think that the way that the question was framed is possibly that it was a proprietary product, and I would say that you need to go with the manufacturer's guidance. If it doesn't say in the guidance, then it probably won't carry the certification or warranty.
Okay, great, thank you. And then I've got a question asking whether the use of timber or steel window frames as cavity closers is based on the assumption that the window actually is in the cavity and closing it, and not incorrectly placed too close to the external face of the building.
Yeah, so it's right. It's on the assumption that the timber part of the window frame is actually within the cavity itself. And so what you're trying to stop here is oxygen, the fire getting oxygen. And so at least 38 millimeters of timber will enable you, if it's within the cavity, it will enable the oxygen to not be drawn from above, providing that there's no gaps there. If the window is sitting forward or to the rear of the cavity, and therefore the window frame isn't really in that cavity space, then it doesn't really cover it as a cavity barrier. You would need to use something else.
Great, thank you. There's a lot of questions coming in, so I'm just going to start throwing them at you, Gary. So here we go. First question from Colin is, should cavity barriers extend below radon barriers?
Radon barriers. Not sure what radon barriers is. Okay,
that's cool. Colin, if you're still online, if you want to just clarify, perhaps we could answer this further. So also, can you ask Gary what temperature an intermittent strip activates?
It does differ from manufacturer to manufacturer, but it's around about 200 Celsius. So you would be certainly looking at closing when the fire gets to around about that point. So the fire could be actually raging from your opening if the fire starts inside the building, and as the fire starts to impinge and the temperature increases, you'll start to see an activation of the charring of around about 200 Celsius.
Cool. The question is, they will keep moving as everyone asks questions. Where was I? Is the requirement for cavity barriers in rain screen cladding, to a masonry construction likely to be changed?
This may refer to upcoming guidance changes this year. The answer is not sure, but what we've seen over the last few years is a number of materials that are not really adequate for use on external walls. And if you're using those sorts of materials, then the best cavity barrier in the world is not going to be adequate to stop fire. So if we're using the guidance for our materials as well as the cavity barriers, then we would say that it's all working. The cavity barriers with the right materials in the external wall system should be adequate, and there shouldn't really be a need to change that. But there needs to be some way in which we stop the use of building materials on our buildings that are really hazardous, and they are not fit for use on external walls, certainly in tall buildings.
Great, thank you. Okay, next question. With regard to surface protrusions through the cavity where you cannot provide a cavity barrier, you say may be able to use a fire collar. What are the criteria for this?
So, yeah, so I'd refer you to look at the NHBC technical extra, but if your design doesn't allow for your flue, plenum, or your ducting to have a cavity barrier around it, it may not be, you know, within the design, doesn't work. Then you could use fire stopping. So, for example, you could use a fire collar within the where the fire line is. The fire line is the part of the fire resistance between the accommodation and the external wall. So you could use a collar there to close down any fire coming from your plenum or duct, instead of when it gets through, that you're protecting your external wall cavity.
Great. Okay, thank you. Got another question, kind of picking back up on the fixings element. So regarding mechanical fixings, could you give suitable material? Could you use suitable materials, e.g. steel screws or alternatives?
Well, you can. I mean, you can use engineering, but the point about it is that it would then be outside of the guidance, and then you need to get approval. So you could have a fire engineer help you design a cavity barrier system that didn't include mineral bats, but used steel arrangements and steel screws. But that would all need to be go through the approval system, and so be proposed by a fire engineer and be approved by the building control and the fire service.
Excellent. Okay, thank you. Now, a technical question here from Paul, who's asked, can we run 150mm full fill cavity insulation, example cavity therm, between two masonry walls with 150mm cavity to meet the window without the need for a proprietary cavity closer around the opening? Just to clarify, are we talking about the exclusion here, where we've got two masonry leaves 75mm thick? Now, if that's the case, then I believe that there isn't a dimension limit to the cavity. Okay. Again, Paul, if you want to pick that one up a bit further, perhaps, then just drop me an email, and perhaps we can kind of talk about that one a bit further. Still loads of questions, Gary, if that's okay. Do you think the materials currently used are fit for purpose and sympathetic to trades?
I'd say it depends what you actually mean. That there are certain materials out there that will make any fire barrier they'll make it useless. For example, polyethylene filled panels, because they're normally got aluminium surface which melts quite easily, and then the polyethylene will burn very easily, and it will spread fire both up and down the building. If you're talking about those those materials, then certainly there may be a place for them in isolated locations only, where there's a very small risk of fire spread. But generally, I'm of the opinion that we should be using materials that are not going to spread fire over the walls, which is not part of this presentation, but through cavities as well.
Right, okay, thank you. Now, I've had a load of you come back to me with regard to the radon barrier. So if it's okay, Gary, we'll just go back to that question if you're able to answer it. Everybody's confirming that a radon barrier would be a damp-proof course. I've just lost it, sorry, hang on. A radon barrier is a membrane normally installed on the ground floor to prevent radon gas from entering the property. So going back to the original question is, should cavity barriers basically extend below that damp-proof course level?
Well, the answer to that is that the guidance is pretty unclear. The guidance is what I would deem to be that it's open to interpretation, and in where you have the example of a barrier stopping radon gas, that would be one risk into the cavity. Where there is a risk of fire entering the external wall, then where you have openings around the wall, even if that's below ground, you should then have a cavity barrier, and also you should have a fire barrier at the compartment floor. So it wouldn't be unheard of to see a fire barrier at the ground floor, for example, if you're using basement and lower ground.
Okay, smashing, thank you. Now, I've got a question here asking, are we likely to see greater control with regard to the installation of passive fire protection? It says, i.e. compulsory use of competent person schemes for the installation of fire cavity barriers, obviously in light of Grenfell recent events. It's just a question that's come through. Sorry,
can you repeat that, please?
Of course, sorry, it just says, are we likely to see greater control with regard to the installation of passive fire protection, i.e. compulsory use of competent person schemes for the installation of fire cavity barriers?
Well, as a professional in the industry, I would hope that, that we're using competence at the moment, but sadly, that's not always the case. In the case of competency for installation of materials, I'm hoping that is going to be addressed by Dame Judith Hackett this year, or even the technical panel for the government for Grenfell. So I'm in the hope that that we can bring a greater level of competency to our buildings, the fire safety of our buildings, certainly.
Excellent. And kind of following on from that, there's a question saying, for fire engineers, is there a minimum qualification or accreditation that we should be looking for?
So for fire engineering, you should be looking probably for someone who is a member of a professional body, such as the Institute of Fire Engineers, and probably chartered engineer status. So at least you've got someone at least chartered engineer status within the company, and that tends to suggest that they are someone who should know what they're talking about with regards to fire safety.
Excellent, that's great. Thank you, Gary. Now, I think I've pretty much covered off most of the questions. Thank you all for sending them all through. It's been a really great sort of Q&A session this morning. So what I'm going to do is give you literally a couple more moments, and whilst you're perhaps thinking of any final questions, just to bring to your attention our next webinar, which will be on 23rd of May, again, a Wednesday at 8 AM. And we're looking at BIM and the digitisation of the built environment, and we're going to have Kieran Parkinson from BSI joining us on that morning. So you'll get a link, you'll all receive an email after this event, and you'll get a link if you want to sign up and join us for that session. Also, in addition, today's webinar has been recorded, so I'll pop that up onto YouTube within the next sort of hour or so, and again, you'll get a link to that. So if you want to share it with any colleagues who may have not been able to attend this morning, who would be interested in the content, please do share the video with them. And also, if perhaps if you joined us a little bit later on or had to go or what have you, then you can obviously catch up. So just want to say thank you very much for Gary. That's kind of all the questions that have come in, apart from a lot of people saying thank you very much. So just passing those thanks on. Thank you for your time for joining us. Thanks to Gary for the expertise. And without further ado, I will see you all next month. Thank you very much.